How's it going, everyone? Welcome, Eulier Gonzalez here. And today, let's take a look now at the closure look at closures, and then on the next chapter, which is the model pattern. So, what a closure is, and once we know the ins and out of lexical scope and how working with variables and how those variables works in different scope and what a scope means here in JavaScript and the different type of scope that we can have, whether it's block, function parameters, functions, name functions or arrow functions, the global scope, and why it is important for us to overexpose variables in a scope, right? For security reasons and for maintainability of our apps. And once we understand that, and this particular topic known as closure, right? Which when you need a variable when you need to use a variable over time and remember that somehow, so closures allow you, is a function feature that allow you to remember the reference of a variable that live outside of that scope, invoke that functions in a different scope, and continue to have access to that reference. So we also look at how can we create a scope, what is a scope or a closure, how can we create a closure not only in the traditional wrapping function, but also as a block, which is another way of how you can create a closure, because at the end of the day, is holding variables reference outside of that scope in the inner function scope, and then invoke the functions to be executed in a different scope from the variable. Okay, so as we explore the closures and how useful for us and how important is anytime that you think or define a closure, is also important to release that closure from memory to be garbage collected. All right, so aka, so you need to remove or release the functions reference to that invocations, so you can get rid of that. So now the garbage collector is getting rid of all of that. So also we look at some other topics, specifically with a question of, hey, is, are we closing over is a variable or a scope, right? And it turns out that when we debug and we look at the observable behavior from the JavaScript engine debugger, it turns out that it actually whole is a reference from that, not the scope. And that's some good news. But in any case, it is also recommended for us to release some memory in a previous scope when that scope is over. All right. Now, as we explore is what a closure is and why we need to have a closure, which now allow us is to organize our codes and make it reusable across different part of our programs. So by encapsulating is now this variables reference that live out in the outer scope from the inner scope, we can now organize our code in a much more easy way and make it clearly the intention of this code. So this is why in today's video, we're gonna now take a closer look to closure and then the next chapter. So as we down a dense chapter, take some deep breath and let it sink in. Seriously, that's a lot of information for anyone to consume. We explored two models of for mentally tackled closures. See, the observational and the implementational. So observational closure is a function instance remembering it is outer variable even if the function is passed to and invoking another scope. This is the observational, right? So we create now a closures around around a variable that we want to remember inside of these functions, and invoke that in a different scope, right? In other scope. And the this is the observation, okay? And the implementation is, so a closure is a functions instance, and it is a scope environments preserved in place while any reference to it are passed around and invoked from other scope. So to summarize, the benefit of our programs or to our programs is that closure can improve efficiency by allowing a function's reference to remember previous determining information instead of having to compute that each time. That's one of the the main topic here of closure. Okay, so hey, we can now hold a reference to this information. So instead of us having to recompute each time, we can just only update that, right? Or hold that there. And the other is that closure can improve code readability, bound scope exposure by encapsulating variables inside of functions instance while still making sure the information in those variables is accessible for future use. So in other words, anytime that somebody is invoking these functions with closures, we're making sure that those information will be held for future access or for future use. The result, narrower, more specialized functions instances are cleaner to interact with, since the preserved information doesn't need to be passed in every location. Exactly. So you don't need to redefine this function scope anytime that you need to. You just define once and then you just make a reference out of that. Before you move on, okay, now this is that chapter. I don't know why this is doing so. Digging. You got it. Why? Exactly. It's like, get rid of this. Yeah, I don't care. Let's reopen that out again. It's not this. It's actually application that I want to check. Window capture is this one that you got. Okay. But it's here, right? Chapter 8. So in this chapter, we wrap up the main text of the book by exploring one of the most important co-organizations pattern in all of the programming, the model. As we'll see, models are inherently built from what we already covered. The payoff to your effort in learning lexical scope and closures. We have examined every single angle of lexical scope, from the breadth of the global scope down through nested block scope into the intrinsicies of the variables life cycle. Yeah, that's right. So from understanding is the breadth of global scope of scope, the different global scopes, and now the variables life cycle in each one of them. So then we leverage lexical scope to understand the full power of closures. And take a moment to reflect on how far you have come in this journey so far. You have taken big step in getting to know JavaScript more deeply. The central theme on this book has been that understanding and mastering scope and closure is key. Okay? Understanding and mastering scope and closure is key, which is when I actually passed particularly I actually went through a coding interview, not coding but just to describe what's going on and things on there, and it turns out that actually that pays off, because I know what's happened. I don't know if there are. I of course I am somebody that has each one of those tasks that they are asking to me. So for example is, well, tell me more about your experience, more about, tell me more about your experience, uh, any difficulty that you have to pass through, how do you solve. They want to know is if you have now a systematic way to approach stuff, right? And the other, the systematic way to approach stuff, and the other is, what about your technical skills, right? And in things that are, so first thing first in that interview was, who are you? Tell me more about your story. Yeah, tell me more about your story. What do you have work on? Go into the technical details of your work. How do you, what will happen when you have an issue? What was the last, so what was the last time you have an issue and how do you solve that? And do you have experience in where we are working, right? This is the 5 topics here of that particular interview, right? Let me actually take notes on that. This is the interview questions, right? Tell me more about your story. Okay, tell me more about you. Tell me your story. Just too big. Tell me your story. Exactly. Tell me your story. Go over your experience. Okay. Describe the tech involved. Why do you use specific tech? Okay. Tell me your story. Go over your experience. Go over your experience. Describe why do you use the tech involved. Okay. And how do you solve a problem the last time you have? How do you solve? How did? Exactly. So how did you solve a problem? How did you solve a problem the last time you had? Okay. And do you technical questions? And do you have experience in our industry, right? That's the 6 topic here, right? And this technical question is to see if you are see how you can describe is this technical questions specifically for JavaScript, right? Technical question here. Hey, about scopes. About exactly. First is about first is about functions. No, first thing was about mapping mapping or array properties. Okay, array methods. Okay, the other was scope. Exactly, array methods. The other was a scope. The other was is scope. Exactly. The other is timers, right? Timers, array method, scope, timers. The other was the how do you put it? Array method, scope, timers. It's like the timers with four of, right? Scopes, and then is object and classes. Object and classes. Okay. Yeah, mainly it was this, right? Array method, timers, scopes, and object and classes. So this was the question that they asked me, right? All of this is in English to see if they have what it needs to be done, if I have that. Okay. Now, so yeah, this is why it is important to mastering a scope is to understanding and mastering a scope and closures is key in properly structuring and organizing our code. Especially the decisions on where to store information in variables. This, when it comes to decisions, yes, when it comes to decisions, especially decisions on where to store information in variables. So our goal in this final chapter is to appreciate how models embody the importance of these topics. The importance of understanding and mastering is scope and closures in properly organizing and structuring our programs and our code, especially when decisions about where to store information in variables. So our goal in this final chapter is to appreciate how models embody the importance of these topics, elevating them from abstract concepts to concrete and practical improvements in building programs. Encapsulation and least exposure. Encapsulation is often cited as a principle of object-oriented programming, but is more fundamental and broadly applicable than that. The goal of encapsulation is the bundling or co-location of information, data, and behaviors, functions that together serve as a common purpose. Independently of any syntax or code mechanism, the spirit of encapsulation can be realized in something as simply as using separate files to hold bits of the overall program with common purpose. If we bundle everything that powers a list of search results, if we bundle everything that powers a list of search results into a single file called search list, Give me a second. Alright. If we bundle everything that powers a list, if we bundle everything that power a list of search results into a single file called searchlist.js, we're encapsulating that part of the program. The recent trend in modern front-end programming to organize applications around component architecture push encapsulation even further. For many, it feels natural to consolidate everything that constitutes the search result list, even beyond code, including presentational markup and styling, into a single unit of program logic, something tangible we can interact with. And then we label that collection the search list component. Another key goal is the control of visibility of certain aspects of the encapsulated data and functionality. Recall from chapter 6 the list exposure principle, which seeks to defensively guard against various dangers of overexposure. This affects both variables and functions. In JavaScript, we most often implement visibility control through the mechanism of lexical scope. The idea is to group alike programs, bits together, and selectively limit programmatic access to the part we consider private details. What's not considered private is then marked as public, accessible to the whole program. The natural effect of this effort is better co-organization. It is easy to build and maintain software when we know where things are, with clear and obvious boundary and connection points. It is also easy to maintain quality if we avoid the pitfalls of overexposed data and functionalities. These are some of the main benefits of organizing JavaScript programs into modules. We have now it is data and it is functionality. We have it is relevant data and it is functionality together. So if we need to use that in a different part of the programs, we can just use that and help us to organize our code better, to build and maintain software when we know where things are, with clear and obvious boundaries and connection points. It is also easy to maintain quality if we avoid the pitfall of overexposed data and functionality. There are some of the main benefits of organizing JavaScript programs into modules. So what's a module? A module is a collection of related data and functions, often refers to as method in this context, characterized by a division between hidden private details and public accessible details, usually called the public API. This is the technical definition, but in my own words, it's like that. So a model is a collection of relative data and functions or methods to divide them between is private and public details. A model is also stateful. It maintains some information over time, along with functionality to access and update the information. Note, a broader concern of the model pattern is fully embracing system-level modularization. A broader concern of model pattern is fully embracing a broader concern of model pattern is fully embracing system level modularizations through loose coupling and other programs architecture techniques. That's a complex topic well beyond the bounds of our discussion, but it's worth further study beyond this book. Because now this is zoom out. Yeah, zooming out here. So zooming out here is this. A broader concern of the model pattern is fully embracing system level modularization. So loose coupling and other programs architecture techniques. That's complex topic well beyond the bounds of this division, but now that we know this concept that is tangible, models that help us to organize data and it is relevant functions. Yeah, data and it is relevant. Yeah, when we have is this, okay, it's a way of encapsulating it is data and it is relevant data, and label it is private and public details, right? When you talk now as system-wide modularizations, this is coming now from the architecture techniques. Okay, is that not only how these small files or the small models actually works together, but also is how now all of these system-wide applications, the service, the mobile, the web, the database, they works together. Or how you can organize that. I think that is. I think that is. It is holy. This is a new level of abstraction. Something that. Okay, makes sense. This is a new level of abstractions. Something that. Jesus. What was the name? Grady Butch, a software engineer, is a chief IBM scientist. Is a chief fellow IBM scientist. Okay. That actually has a series of interview with different podcastees and so on and so forth. When he described is that now the software architecture or the software engineering field is one of rising level of abstraction, because we're starting to deal is with this different kind of problem. So it's not more about is how can we organize our code, how can we make these programs, how can we make the data and it is functions, bundle it together, so we can now use that and reuse that code in different places in our programs, right? And label that by private and public details. But now it is more about is what cloud service do I use? What servers do I need to write this up? This has more concern. This is less of software engineering problem and has more impact on the economic problems. So to get a better sense of what a model is, let's compare some model characteristics to useful code patterns that aren't quite models. Namespace, stateless grouping. If you group a set of related functions together, like this, without data, then you don't really have the expected encapsulations a model implies. The better term for this grouping of a stateless function is a namespace. Yeah, if you group a set of related functions, okay, namespace. To get a better sense of what a model is, let's compare some model characteristics. Okay, model characteristics such as similar as closure, that is a function characteristic, and the this or the object, the what do you call it? The the prototype object programming, okay, or the way of delegating is now property access to other objects, okay. So let's compare some model characteristics to useful code patterns that aren't quite models. So for example, namespace, stateless grouping. If you group a set of related functions together without data, then you don't really have the expected encapsulation a model implies. The better term for this grouping or stateless function is namespace. Okay, so you are now is encapsulating its functions, not its data. Okay. Utils here is a useful collection of utilities or functions, yet they are all state independent functions. Gathering functions together is generally good practice, but that doesn't make this a model. Rather, we have defined util namespace and organized the functions under it. The other is a data structure, stateful grouping. Even if you bundle data and stateless, okay, even if you bundle data, which is that what the object is doing here, if you bundle data and it is stateless and it is, you bundle the data and stateful functions together, if you are not limiting the visibility of it, of any of it, then you are stopping short on the pole aspect of encapsulation. It is not particularly helpful to label that as a model. So even if you have a functions encapsulating or a data and it is function encapsulated, right? This is interesting because this is known as namespace. Namespace, not a model. And then you have the data structure and not a model here. Since record is publicly accessible data, not hidden behind a public API, student here isn't really a model. Student does not have the data and functionality aspect of encapsulation. Okay. Exactly. Student does have the data functionality, data and functionality aspect of encapsulation, but not visible control aspect. It is best to label this as an instance of a data structure. And then you have model, stateful access control. To embody the full spirit of model pattern, we not only need grouping a state, but also access control through visibility. Private versus public. And let's turn students from the previous sections into a model. And we'll start with a form I call the classic model, which was originally referred to as the revealing model. When it first emerged in early 2000, consider. Okay, let's turn student from the previous section into a model. Okay, so we're gonna hide it is inner behave, it is inner implementation. How do you gonna do this before even take a look at the code, right? So we'll start with a form I call the classic model, which was originally referred to as the revealing model when it first emerged in the early 2000s. So if we want to, for example, now encapsulate this, right, into its own model, what we can say is, well, let me now hold this, and instead of encapsulating data and its functionality, stateful data, or the stateful grouping, right, in this way, I do want is to now wrap them into a function, okay, that I do want to call is create student. All right, it's gonna do this, create student. And then inside of this, define now a function wide variables like var, and this one as well. So say function get name as it is, and let me now expose is only the data that is relevant to, right? So here we got is the record, right? We can call this record, and since we are now using is this, we can say, hey, if you have now a record, make this record here, or whatever you receive as record, okay? Define the functionality here that is going to work with this data, and then only expose is the data that you need to. In this case, we can do something like this. So return is the get name, right, as an object. So we are encapsulating is now these details here, right? I'm encapsulating is detail and returns you that, okay? Because I do want to now have access to this get name, or this exactly. So this will actually work as intended. Say student get name is not a function, because we need to return is this get name. Function is already there. We are returning is an object that contains now the get name, okay, in this context. So we're assigning is this function expression, all right, and we need to execute that, okay. Okay, makes a lot of sense. So we need to actually is execute it, because this is just the definition. We haven't invoked this function, and if we want to invoke that, well, let's going to now wrap this as it is, and then immediately call that function, and then this will work as expected. Say, hey, cannot read property of find get name anonymous here of this, right? Dig var student. Oh, is exactly. It's because it's not a this, it's a record, all right? So we are now accessing to variable from the outer scope, okay? We're creating is a close over the records, okay, and then find data, and now it'll work as expected. So look at what we have done, or how we transform this. This is now new syntax, right? I must admit that this is new syntax, but look at what we transform this, okay? So by saying is, hey, let me now wrap the data and it is methods, and encapsulate that and hide the details, all right, as they mention here, and And label is the hidden and label a division between, yeah, and label, and divide, okay. So and divide is between hidden and public accessible details, as it is. And exactly. So by encapsulating its data and its methods, uh, and divide the hidden private details and public details, all right, we are now is controlling is the access of this data and the functionality here. So as you can see here, this is pretty much like you put it here, right? You assign this as a public IP. This is actually much more descriptive than just returning is that, all right? But it turns out is fairly similar of what I did here. So student is now an instance of a model here. It's now an instance of this. It features a public API with a single method's get name here. This method is able to access the private hidden records data. Warning, and should point out that explicit student data being hard-coded into this model definition is just for an illustration purpose. A typical model in your program will receive this data from an outside source and typically loaded from a database, JSON data files, AJAX call, etc. But the data is then injected into the model instance, typically through methods or model public APIs. So how does the classic model format works? Notice that the instance of the model is created by the defined student immediately invoke function expression being executed. This immediately invoke function expressions returns an object named the public IP that has a property on it referencing the inner get name function. Naming the object public API is a stylistic preference of my part, exactly. So the object can be named whatever you like, and GS don't care. Or you can just return the object directly without assigning it to any internal name variable. More on this choice in Appendix A. So we take a look at the Appendix A. Missing who am I? Arrow functions. Talking about the arrow functions. The case of var, where it all start, asynchronous, asynchronous callback seal closures, synchronous callbacks. And synchronous callbacks. And defer to close in classic model here. Chapter 8 explain the classic model pattern, which can look like this. So you're going to receive now, so define models is a student, you're going to receive is the elements, the public API, and render that list as it is, okay? And then return is the public API. And then somehow you're going to now pass is the student data. Notice that we're passing students another model instance. It's a dependency, but there is a lot of useful variation in this model from you may encounter. Some hints for recognizing this variation is, does the model know about its own API? Even if we use fancy model loader, it's just classic models. Some models need to work universally. Where is my API? First, most classic models don't define and use public API the way I have shown in this code. Okay, most classic models don't define and use public API the way I've shown in this skill. Instead, they typically look like this. So they just return is this. The only difference here is a directly return the object that serves as a public API for the models, as opposed to first saving it to an inner public API variable. This is by far how most classic models are defined, but I strongly prefer and always use myself the form and public API form. Two reasons. Public API is a semantic descriptor that aids readability by making it more obvious what the purpose of the object is. Exactly. So it make it clearly what is this doing. Storing an inner public API variables that reference the same external public API object return can be useful if you need to access or modify the API during the lifetime of the model. Storing an inner public API reference the same external public API object can be useful if you need to access or modify the API during the lifetime of the models, which is something that you shouldn't do. But in any case, so for example, you may want to call one of the publicly exposed functions from inside the model, or you may want to add or remove methods depending on certain conditions, or update the value of an exposed property. Whatever the case may be, it just seems rather silly to me that we wouldn't maintain a reference to access our own API, right? Yeah, that's good to say. Asynchronous model definition, or AMD. Another variation of the classic model form is the AMD style models, popular several years back, such as those supported by require.js utility. So you define now the place where you are, okay, the location, and the functions declaration. If you look closely at student list here, it's like somehow it's injecting this. It is a classic model factory inside of the machinery of define provided by require.js. The student list function is executed, passing to it another model instance declared as dependency. Exactly. So inside the machinery of define provided by require.js, the student list function is executed and passing it to any other model instance declared as dependency. The return value is an object representing the public API for the model. This is based on exactly the same principles, including how closures works, as we explore with classic models. And then you have now the universal models, the UMD. The final variation we look at is UMD, which is less a specific exact format and more a collection of very similar formats. It was designed to create better interop without any build tool conversions for models that may be loaded in browsers by AMD style loaders or in Node. I personally still publish many of my utility grades using a form of UMD, utility libraries. Here's a typical structure of the universal model. So given is the name, the context, and the definition, loaded by AMD style loader. Type of define, if this is a function and define has a property called AMD, so let's go to call this define here, followed by the definition. If this is in Node, let's check if this is the type of model is not undefined. Okay, so depend on the co-organization and the environment that you are, you might say, hey, I am in the browser. If it is, it's because that this is now a function and that object has an AMD. Okay, and therefore I'm going to now is pass the definition and inject that to this model organization. If it's not, let me check if this is a node model. Okay, and then export that, the definition of this, or assume the standalone browser script. So if this is in a context name, all right, so the definition will be is now the name and the context. So with this, all right, this is the okay, this is the check. This is the initial check of this. Holy moly. This will of course going to execute first thanks to the immediately invoked function expression, and then as a parameter you're going to receive is now the student list, which is the name. You're going to receive is the context, and then you're going to receive is now this function here, okay, which is the definition here. Though it might look a bit unusual, UMD is really just an immediately invoked function expression. It's because it's making some checks here. Okay, it's making some checks before it's going to accept this. So what is different in the main, in that what's different is that the main function expression part at the top of the immediately invoked function expression contains a series of if statement to detect which of three supported environment the model is being loaded. Exactly. Whether it's on the browser or is loaded by an AM style loader, or whether it's on Node, or if this is a standalone browser script. The final parenthesis that normally invoke an immediate invoke function expression is being passed three arguments: student list, the name of that model, the this, and another function expression. If you match those arguments to their parameters, you will see they are exactly name is this, context and definition here, right? Student list's name is the name label for the model, primarily in case it is defined as a global variable. Primarily in a case it is defined as a global variable. Okay. Okay, primarily defined as a okay, that makes a lot of sense. Add that to the context. If this is now running on the global scope, the browser global scope, add that to the context, all right, and then assign this value to this, which is the definition here, which is this, the definition, which will be provided is now the name of that, followed by the context. And then it's supposed to return now is an object here that it contain is the model data and it is functionality, specifically the public API. respectively. Student list name is the name label for the model, primarily in case it is defined as a global variable. This context is generally the window, aka global object, and seen in chapter 4. Exactly. So this context here is the window here, the global object that you are referencing. In this case, exactly. In this case, for defining the model by its name, definition is invoked to actually retrieve the definition of the model. And you will notice, sure enough, that just a classic model form. And the definition here is just a classic model form. Exactly, it's just a classic model form where containing it is data and it is methods, and only expose the and divide is what is a private and public information, public details. Okay. Holy moly. There is no question that as the time of this writing, ESM, ES model are becoming popular and widespread rapidly. But with millions and millions of model reading over the last 20 years, all using pre-ESM variation of classic model, they are still very important to be able to read and understand when you come across them. Okay. Okay. Exactly. This is not as low level technical or algorithm step by step. This is a more, we zoom out we zoom out in terms of our needs. Okay? Or I zoom out in terms of the need of the program, in terms of the need of the programmer. Okay, which is organize our code based on its data and its functionality, and divide what and divide what is and divide those private and public details. So from the odds, so we are is here, right? Exactly. On the appendix A. So from the outside, student.getName invoke this exposed inner function which maintain access to the inner records variable via closure. Exactly. So it maintains access to the inner variable records via closure. You don't have to return an object with a function as one of its properties. You could just return a function directly in place of the object that still satisfies all the core bits of a classic models. By virtue of how lexical scope works, defining variables and functions inside your outer model definitions, functions makes everything by default private. So exactly, by virtue of how lexical scope works, defining variables and functions inside your outer model definition function make everything by default private. Only properties added to the public API objects returned from the function will be exported for external public use. The use of and immediately invoked function expressions imply that our programs only ever need a single central instance of the model, commonly referred as a singleton. Indeed, this specific example is simply enough that there is no obvious reason we need anything more than just one instance of the student model. And then you have the model factory. It's creating its multiple instances. But if we did want to define a model that support multiple instances of our program, we can slightly tweak the code. Okay, so if we need to generate is now multiple instances of our program, instead of returning is just one single one, and if we want to return is multiple ones, okay, we can is just call this, so wrap this function here, okay, we just call this function here and assign it to a new variable by defining it's just a function here, you know, as it is. Factory functions, not a single term, immediately invoke function expressions. You just define a function here, right, with all of the definition, and then later on, you just is create a new instance of that. And then you assign to an identifier, aka a variable, and there you got it. So rather than specifying define students as an immediately invoked function expression, we just define it as a normal standalone function, okay, which is commonly refers to this as a model factory here. We then call the model factory producing is an instance of the model that we label full-time. Define student full-time, this one. This model instance imply a new instance of the inner scope, and thus the new closure that get named. This model instance implies a new instance of the scope in the function scope or the inner scope, and thus a new closure that get name that holds over student, hold over this record here. In full-time get name now invokes the method on that specific instant. And then you have now the classic model definition. So to clarify what makes something a classic model, there must be an outer scope. Okay, so to clarify what makes something a classic model is there must be an outer scope, typically from a model factory functions running at least one. The model inner scope must have at least one piece of hidden information that represent the state for the model, that represent is what, okay, that represent is the state for the model, and the model must return on its public API a reference to at least one function that has a clause over the hidden model state, so that this state is actually preserved. You will likely run across other variations of this classic model approach, and we will look at it in more detail in Appendix A when we dive deep into that. So for example is here the classic variation of the model. And where's my API and all of these different models definition here? Node Common JS model. In chapter 4, we introduce the Common JS model format used by Node. Here's what we're describing is the different ways to organize our code in the environments where the global scope live. Unlikely the classic model format described earlier, where you could bundle the model factory of an immediately invoked function expression allowing any other code, including other models. Common JS models are file-based. one model per file. Exactly, one model per file, and they are file-based. Models are file-based. So let's tweak our model example to adhere to that format. So in this case, because they are file-based and they expose certain properties, for example, models, so they inject those into this scope, export, then you add the property get name to do so. So the records and get names identifiers are in the top level scope here, right? Exactly, are in the top level scope. That's not the global scope I explained in chapter 4, because this is not a this is a per file. Okay, this is per file, and per file in this case in the CommonJS model is like wrapping in its own scope closure. If you want to have access to the global scope, you need to do that explicitly, okay, to append the variable and functions to the global scope. This is true for CommonJS and EX6 models as well. So their identifiers, var and functions, are automatically attached to the global object if they live in the browser, if this code is executing in the browser or in a service worker. But if this code is executing in Node, whether it's CommonJS or EX6 models, they're not automatically attached to the global object. You can, of course, but you have to do that explicitly. So to expose something on the public API of a CommonJS model, you add the property to the env object provided as the model.export. In some older legacy code, you may run across reference to just a bare export. But for code clarity, you shouldn't always fully qualify that reference this with the model prefix. For purpose style, I like to put my export at the top of my model implementation at the bottom. But these exports can be placed anywhere. I strongly recommend collecting all of them together, either at the top or bottom of your file. Some developer has a habit of replacing the default export objects like this, defining a new object for the API. So this file model is exposing these details. And there's some quirk with this approach, including unexpected behavior if multiple such models circularly depending on each other. As such, I recommend, okay, there's some quirk with this approach. By exporting this as an object, including unexpected behavior if multiple such models circularly depend on each other. As such, I recommend against replacing the object. If you want to assign multiple export at once, using object literal style definition, you can do this instead. Model export dot assign, okay, the assign dot create. Okay, let me refresh here about the object dot assign. Object dot assign dot create, because it say, hey, let me now assign to this target this and replace this source. So they're going to be overriding this. Static method copy all enumerable on property from one or more source to the target object. The object.assign, what it's doing is copy all the enumerable properties from the source to the target. So in other words, if you are doing this, okay, you having is now so let's say is var model var model here, say model 1, right? And then you have now A with 1, B with 2, right? And then you have now a var model 2 here to say B, because it's gonna copy all the enumerables own property from the source to the target. In this case, this, right? And you do this, you say model 1, model 2, and then you say object.assign, exactly, it assigned all of this own enumerable property from the source, which is model 2, and copy them into the model 1, right? Console log is doing this. Exactly. This is actually pretty much the same to do is in this. Model 1. So go over to own it is enumerable properties. It is own enumerable property. This is true? I do think it is. This is the spread operator. This spread operator on the ECMAScript. On the spread operator, or the spread element here, as it is. Are they going to describe how the things actually works? The spread element here, this one, right? This one. Is going to look. The spread element is saying, hey, is this assignment expression? And this assignment expression, it can be anything of this. All right. If this assignment expression now return is now an iterable, all right. If this is now an iterable, let me actually if this is now an iterator, So let me get the iterator here. It's like, let me now evaluate is this. Let me evaluate that assignment or that expression, and then get the value and check if the value here of the spread object, right, contains now an iterator. Get iterator here. Okay, if that is an iterator. If it has an iterator, which is in our case is this, if this has an iterator, I want to go over all of this, so call all of these elements there. Perform the create data property or throw create data property, right? Create data property here. And the same for this model 2 is this, but it's a rest parameter must be the last formal parameter. So if you do something like this, to say model 2 and then so if you want to spread all of this object here, you can do is model 1 here. This will gonna spread is the keys, right? So if you say something like this, hey, I'm gonna create a new object that will have is in this model 1, right? So spread this element here. But the other is to do this model 2, right? Of course, because I already modified that. It's because I already modified that. No, it's because I already modified that. Right? If I say something like model 1 and then model 2, is this one, right? But if you only have is the model 1, you got is this. Okay. This is what object assign is doing here. So what's happening here is defining is a triple object. Well, that'll be all for this video. Take care. Bye-bye.